Okay. I have prepared something. It's called Compiler Explorer at Home. It's a talk mainly about Compiler Explorer. Maybe first things first, you don't need to know much about me, but just remember one thing. I used to be a library developer in central R&D. I want to provide a little story today, and that's the one fact you maybe could remember. It would be nice for later on. If you want to know more about me, I will be around afterwards. But, right. I want to start in the presentation by dissecting my presentation title. So what is Compiler Explorer, or Godbolt as it is often referred? It's basically a live compiler and a live executor of many languages of code. And I want to just show you basically. So I have a couple of examples here. If you go to compilerexplorer.com or to godbolt.org, it leads you to the same page. You basically see something like that. And I think what the origin of the project was to really inspect what the compiler gives you. And how can you inspect it? Basically by diving into the disassembly of your code. And I brought a short example here. So what do we see here? We have basically an editor window on the left side. Then we have the assembly output on the right. And if we look around here you can basically choose your programming language. So it's not just about C++, but basically any language, I guess. And it's also not only about one compiler, but really about every compiler out there. So it's ridiculous. So every compiler you ever could think about, you will probably find here. So this first example, I wanted to play around a little bit with compiler flags. So I brought a stupid example. We have a function, and it iterates over this variable here. So 5,000 times, and we just accumulate the iterator. So and then we return the result. So if I now compile this with a fairly recent GCC version and with optimizations completely turned off, so here I can specify compiler flags. I basically get an assembly how I would expect it. The compiler just naively did what I told him to do. So if we enter the function, we move some stuff around, basically, and then we jump to L2 here. In L2, we compare the iterator variable against 4,999. And if we are less, we jump to L3. And if we are not less, we basically leave the function. And at the L3 tag, basically those are the two add operations we are doing here. We add the iterator variable to value, and then we increment the iterator variable here. So, and now the price question. What happens when I turn optimizations on? Right? The compiler is smart enough to not compile stupid code, and the compiler just does the calculation for you and returns the result. So I know that's kind of a stupid example, but it just shows you can play around with the flags you want, and you immediately see the result. So the feedback loop is really, really fast, and that's nice. So then you can not just view the assembly output. Basically, you can also execute the code if we tick the box here. And of course, we cannot execute anything here because we have no main function. What shall be executed then? But I have another example where we execute the code. It's the demangle function is not that interesting. It just demangles the symbol. So That's not interesting, but I have a short example where I initialized a vector of bools, and then I just accessed the first element, and I demangled like the type of the element variable. And what a naive C++ developer would expect here is, of course, if you access a vector of bools, you will surely get a bool, right? So, so I just printed for reference what is the type reference of a bool. It's bool, makes sense. But for whatever reason, elements of a bool vector are no bool then, but the bit reference, yeah, maybe you know the story here. I don't always have such advanced folks around my talks, so I hope you had a chuckle. Anyways. Right. And it doesn't even stop here. What another really nice feature is IDE mode. And in IDE mode, you even can write a CMake. So if you turn on IDE mode here, you see a little tree window, and what works here, you can just create more than one file if you want to play around with stuff, maybe with header, with includes, whatever. You can switch to IDE mode, you can have multiple files, and you really also can write you can write a CMake file, so if you want to debug CMake or whatever, that's that's really nice because it's just so interactive and it just works. So that was that. And I recently saw a video with Matt Gottbold, like the founder of Compiler Explorer, and there he told in the video that they even added now GPUs as runners. So now you can, I'm not a CUDA programmer by any means, but I found it very interesting that you can write CUDA and you can not only compile it to the x86 assembly and the CUDA assembly down here, but you also can write your code on NVIDIA graphic cards, which is really nice, I guess, if you're into CUDA. So, right, so why is this guy up here and talking about Compiler Explorer then? So, because as I said, I was a library developer, and often colleagues came to me and they had like 3 lines of code and something was not working or they used it wrong. And it was always kind of annoying because we were developing on main, which is like version 5, I don't know, of your library, and they came to us with, yeah, I have this bug in version 2.5. So now you have to go back to compile the stuff. It takes ages. Then you have to deal with Conan. Maybe they messed up your local cache, then nothing worked anymore. So, and that was the point when I remembered that with Compiler Explorer, there is this feature that you can integrate libraries. So I didn't show it right now, show you later. But I used it like only once or twice to explore something in Boost. And that's when I thought I need something like this. So not really open source libraries, maybe also open source libraries which are used very heavily throughout a company, but I need Compiler Explorer with our inner source code, so it's not really open source. It is not on GitHub or anything, but it is like public to the company, so everybody can use it, can use our libraries. It's something like open source inside the company. And I needed that if anybody comes to me, I can compile just the 3 lines of code without any hassle and can play around, figure out what the bug is. So then, yeah, I sat around and thought, how hard can this be? And it was one evening, was like around 5. I thought, yeah, maybe just clone it. It takes a short while. It's a big repository. Then, like, go into the directory and hit make. It's sped up a little bit, so npm is not that fast. But it takes around, I don't know, 2 minutes. There are some errors, never mind. It will work eventually. So, and then after like 2 minutes of compile, I could launch a Google Chrome with localhost. It's localhost and port 10,240, and you have a working, that's not what I intended. Just stop it here. And you have a working Compiler Explorer instance on localhost, which is quite nice. Chef's kiss of a developer's experience. It's maybe a bit the overstatement. I had to install npm and Node.js. That's a bit of a hassle, I guess, but it was fine. So, and like with that nice experience, the idea was born to just go further and try to achieve this. So, what were the next steps then? Basically what I did, I ended up forking Compiler Explorer. There are some configuration files. It's really easy to set up. And for the compilers and tools, which are quite static configuration, like they change when I update my Docker container, that is not common, so maybe once a year. So I just like hard-coded my new configs with my compilers, which I found, pushed it to my personal internal GitLab space, right? And how does this configuration look like? It's this properties format. So you just define your compilers, which for me is just GCC and Clang. Then I have like a handful of versions, like from GCC 9 to 14, and basically 6 Clang versions. So this was like done in an hour, I guess. And that's quite static. Once in a while I add a compiler, but that's not that often. So what is more dynamic is to integrate the libraries. And what I do here is I just then run a Docker container. I install my compilers, you just saw. Then I pull the Compiler Explorer repositories, and then probably the biggest hassle is to get all the libraries via Conan. We use Conan Write a lot in the company, and if that worked out, which is maybe the trickiest part, you can just parse the Conan build info.json, just get all the paths you need, like include paths, library paths, and library names. With that, you have to patch the config file again, and basically then you can just run make, like you saw in the little video, and it will work. So what do you have to patch for the libraries? It's basically you have to give him a list with all libraries you need. Then you have to specify the versions you want. And down here, it's like you have to specify the path, which means the include path here, and the lib path, the library path to all the shared objects. Right. And with that, I will show you what works. We have to switch the machine real quick. And maybe first thing first, I can show you there's like one Docker container which maps the port 10,240 to port 7777 of this machine. And that's why on localhost 777, now there is a Compiler Explorer instance. And here in the library field, you can see the 3 libraries from the slide. That is 2 Rohde and Schwarz libraries down here, and the widely known libarchive, I guess. And for example, if we now link against libarchive 381, we can see it actually tells us that it is linked against library libarchive 381, and if we change it, it will change there as well. So seems to work, right? Maybe one last thing, I wanted to show you that it actually works also with Rohde and Schwarz libraries. So serialization, R&S serialization is a little serialization library which lets you serialize annotated C++ classes into JSON and other stuff. So we have the R&S namespace here, and yeah, I can serialize the data object class, which is annotated here into some JSON. Right. So that's basically all I had for you today. I linked a couple of things here. I don't know if the slides get uploaded, but if there is a link to the Compiler Explorer GitHub, there is a link to the video of Matt, which I referenced. And down here, there is the examples I showed at the beginning. And yeah, thank you for being here, and have a nice evening. Any questions? Fine. Yeah.
I just wanted to ask, in your Compiler Explorer, can you also see the assembly of the code?
Yes. I could have shown in more detail. So here you see I only have a couple of compilers, not as many as before, but the assembly is here. Like, it looks really weird because serialization has a lot of context for stuff, but that's the assembly, right?
One more question here.
I just want to ask how many compilers you have and if you have all them installed.
I have like 12 compilers, like GCC 9 to 14 and Clang 14 to 20. They are all installed in the Docker container, but it's just like the one version of Clang 14, which is like in the Ubuntu repository. So you cannot get like 14.1 and just one per major version.
Have you tried that with MSVC?
No. I know that like on the original Compiler Explorer there is of course MSVC and there are also Windows runners, but yeah, it's fine for me. Like, I didn't saw the benefit. The error messages are best in Clang anyways, so why would you use MSVC? Yeah.
A small question here regarding the compiler options. So if you have the compiler options which is provided from your profiles, can it be updated on the top, like where you select the compiler which you have chosen? So right next to it you have the compiler option.
Yeah, you have to here you can specify compiler options, and what you also can do. I think I quickly skipped over it. You can here you can specify like static compiler options which are always applied in the properties file. So, for example, here for GCC 14, if you want to put, I don't know, -std C++23, you could put it here and it would be always applied. Or you can apply it manually. Yeah.
Is it possible to download binary, for example, or if it's possible to compile the library and download it in Compile Explorer?
You mean the executable which is compiled on the fly? I think you cannot download that binary. I'm not sure actually, but I don't think so. And the library is like compiled in the container. So it's not compiled always on the fly. It's like a static, like a shared object or like a static library, which is just linked. Yeah.
Thank you.
Right, and we have one last question.
Do you have tried to use CUDA, or do you know if the GPU is supported in this at-home version?
In my at-home version, no. I have no graphics card which can run code. So you need dedicated runners for all the different platforms. So I think on the godbolt.org you also can run on ARM, and I don't have any ARM machine, so I cannot run ARM code. Yeah. So it's really stripped down. Yeah.
Thank you for the talk. I'm more interested in what is the typical use case for it? I see that it's useful, but I'm just curious for what you actually use it.
It's a very good question. It's basically, I think it's two main use cases. On the one hand, I can give a short example to a colleague which is maybe not familiar with my library, and I can give it to him and he can play around. It's not just like in the README of the repository, but he actually can change code and he will see if it compiles, or she will see if it compiles or not. That's the one use case, and the other one really is I get a bug report with just a couple of lines, and I want to reproduce the issue. And not always only with the main version, which is on my computer anyways, but with any version which is ever been released on the internal servers. Yeah. Right. Then, thank you. I hope it was okay.